Hey guys, this is Lee again, bringing you another video on simultaneous equations. My last video had some issues, so hopefully this one will be somewhat better. I'm speaking a little bit louder, so hopefully that will make it a little clearer. So in the last video we looked at solving simple linear simultaneous equations, and the example that we had, or one of them rather, was y equals 3x and y equals 2x plus 1. And we said that when you have equations like this, y equals something, you just say that it's 3x is equal to 2x plus 1. Subtract the 2x off both sides, so 3x take 2x is x. Then this side then will just be 1. So in this case here, very easy. You know, we've got x straight away, and that's good. Substitute that back into one of our equations. So if I number these equations here so that we can refer to them. So if we substitute this value of x equal to 1 into our first equation here, we can calculate a value for y, in this case 3 times 1, nice and easy, 3. So that is now our solution. These two straight lines intersect at the coordinate 1, 3. Now it's good technique, good exam technique to substitute these values into this one here to see, you know, do your answers, you know, if you substitute these in here, you know, do you get the same answers back out? So y equals 2x plus 1, so x here is 1, so 2 lots of 1 plus 1, so that's 3 altogether. 2 lots of 1 is 2, plus 1 is 3. And does that come out as what we were expecting? We were expecting 3, yes, okay, that's good, yeah, so that means it's almost certainly correct. So this solution here is almost certainly the correct solution for this. Sometimes maybe you make a mistake somewhere, you know, when you do this final check, you know, you realise that you've made a mistake. Good exam technique, bear that in mind, folks. So let's take a look at a slightly more unusual case. I say unusual, it's just a slightly different way of writing them, I suppose. X plus y, subtract 3 is equal to 0, and x plus 2y plus 1 is also equal to 0. So I have to admit, this is the first time really I've saw a set of simultaneous equations where they both equal 0. I've honestly never seen an example like this, but it's a good example to have. So there are a few different ways that you can tackle this question, and this is one of the things that can make maths quite easy for a lot of people, and also the thing that makes maths quite difficult for a lot of people. It's the fact that there's no one set method to solve problems. There are lots of ways that you can approach a problem. So in this case here, I'm just going to label the equations number 1 and number 2 again so that I can refer back to them. What you can do here is you can do equation number 2, subtract equation number 1. So you could do that. If you do that, then you'll have this equation here subtract this one. So you'll have x subtract x, which of course, you know, is nothing. You'll have 2y subtract y, which is just y. And then you'll have 1 subtract negative 3, so that will end up being a positive 3 there. So 1 plus 3 is 4, and then 0 subtract 0 is still 0. So then in this case then you can work out then that y is equal to negative 4. Once you then have that value, you can substitute that into equation 1, and you can say that, okay, well, x is x plus y, in this case minus 4, minus 3 equals 0. So this here is x minus 7 equals 0, or x is equal to 7. So we then have our coordinate our point of intersection, 7 minus 4. It's good practice to substitute that into equation 2, does it all work out correctly? So equation 2 is x plus 2y plus 1, and it should be 0, so let's see if that's the case. 7 is our x plus 2 lots of y, which is minus 4, plus 1, and let's see what that comes to. 7 plus this here is minus 8, so minus 8 plus 7 plus 1, well 7 plus 1 is 8, minus 8, 8 minus 8, 0, yeah, that's good. So that is almost certainly the correct answer to that question. So let's have a look at a different example, or in fact no, actually let's have another look at this one, because I did say at the start there are a few ways that you could tackle this. So in the case there we said that doing equation 2 minus 1 is one method of solving it, and another method is to rewrite both of these equations. So this one here would be x is equal to 3 minus y, and this one here will be x is equal to minus 1 minus 2y, or you could factorise that and say it's 1 plus 2y. Doesn't really matter. Negative 1 plus 2y. And then you can solve that then very much like this one. You can say that 3 minus y is equal to minus 1 minus 2y, and the steps will be the exact same as this. So that's another way there that you could work that out. So let's take a look at another example. If I take that away. So let's try y equals x minus 6 and y is equal to a half x minus 4. Okay, so this one here, it works the exact same as the last couple of examples. You can do it the same way. You can say y is equal to this, y equals this. Quite straightforward. X minus 6 is equal to a half x minus 4. And then with this example here, if we subtract this half x off both sides, x subtract half x is 1 half of x. Minus 6 is equal to minus 4, and then if we plus 6 onto both sides, so a half x is equal to minus 4 plus 6 is 2. And then to get x on its own, we don't want 1 half of x, we want x times both sides by 2. 2 times 2 is 4. Substitute this into equation 1. Y is equal to 4 subtract 6, which is negative 2. So then our point of intersection. And you'll notice that I keep saying point of intersection. I'm saying that because these two equations here represent straight line graphs. And as they're both straight lines, as long as they're not parallel, they will always have one intersection point and only one intersection point. And that's what we've calculated here. And then, same as in every other example I've given, substitute these values back into here. Does it all work out as it should? So y is equal to a half x. Now in our case, x is 4. So that there is 2 minus 4, which is minus 2. So y is minus 2. Did we have y as minus 2? Yes, we did. So that is almost certainly the correct solution. Now, sometimes you'll have questions that aren't quite this easy, aren't quite this straightforward. Sometimes maybe you'll have something like y is equal to x plus 2 and y is equal to x squared minus 4. Okay, well you can still start this using the same approach. You can start by saying that this is equal to this. X plus 2 is equal to x squared minus 4. Now it's important here that you recognise the significance of this. It's important that you recognise, because it has an x squared term in there, it's a quadratic equation. If you ever see a quadratic equation, always try and get it in the form ax squared plus bx plus c equals 0. In other words, make it equal to 0. So here we want to get this x plus 2 on the other side. So we need to take away x, take away 2 from both sides. So we'll get 0 is equal to x squared minus x minus 2 minus 4. So the x squared and the minus 4 are still here, and I've just subtracted x off both sides and subtracted 2 off both sides. And then you can simplify this. You can collect the like terms. In this case the like terms are the digits, the numbers, minus 6. And then we have this. And then you need to be able to factorise this. So I think I'll make a note of that at the end of the video, and I'll make a video specifically about factorising. But factorising is where you put it into brackets like this, and in this case it's minus 3 and positive 2, or at least I hope it is. And then you say then that one bracket is equal to 0, so either x is equal to negative 2 or positive 3. So we've got two solutions for x. You put those two solutions in and you'll get the solutions then for y, and you've got to make a decision on what makes sense, because sometimes you can get dodgy responses. But put these into y here. We have y is equal to minus 2 plus 2, which is 0. So one equation there, or one coordinate I should say, is that. And the other one will be 3 plus 2, which is 5. So there are two equations. Now what I was saying there about, you can sometimes get dodgy responses, is if I very quickly sketch this, x squared minus 4, something like that, x plus 2, something like that. So here we've got two solutions. Do these make sense? Minus 2, 0, yeah, that's about right. 3, 5, yeah, that's about right. Yeah, okay, so we're okay there. So I think I'll leave this video here. I'm not sure how long it's gone on for. I could do with getting a timer in front of me, just so I can make sure that my videos aren't too long. I don't want to rush over things too quickly, but at the same time, I want them to be bite-sized chunks. There's no point trying to sit there in front of a video for a full hour trying to make sense of something. I think when I edit this video, I think I'll insert breaks as well, so that you can attempt the questions. Yeah, so I think I'll leave it there. So please comment down below if you've got any more suggestions. Yeah, I'll see you next time.